Hi, everybody, and welcome to Distance Learning. Hope everybody's doing well, and congratulations, you get to hear my voice even though you are in the comfort of your own home currently, I hope. Anyway, welcome back. So as I mentioned before, we are going to go ahead and pour through the last couple of short chapters here that we were going to do right after spring break, and kind of just go ahead and complete the curriculum for the Math SL course. And of course, since you're not taking the exam, we can cut back on the review topics. We pretty much reviewed all of last year. We were looking just to start reviewing the calculus and the statistics portions. We'll go ahead and just finish up the statistics lessons, I think, and there are the probability lessons here in chapters 23 and 24. Not quite at the same pace that we would normally do in school, so we're going to slow things down a bit because you are at home, and I want to make sure that we don't overburden you. But follow along in the course modules for each week's assignments, and we'll see about answering questions and help you along the way to get from there. So today we're going to start on chapter 23. This is 23A, and this is called Discrete Random Variables. So feel free to take notes. I will also post the completed notes in our notes section like we always do anyway. But if you want to follow along and take notes, you're more than welcome to do so. So starts off with the definition of what a random variable is, and it talks about a random variable, not necessarily something that you just pick without any form or reason that we might think of the word random. But here, a random variable represents the possible outcomes that could occur for some random experiment. So we're going to talk about the possible outcomes that we have. So for instance, there's two types of random variables. There's the discrete random variable that we're going to focus on, and there's also a continuous random variable we'll talk about later. For right now, the discrete random variable is when a variable has a finite number of outcomes. So for instance, the examples that it has here, the number of new bicycles sold or the number of defective light bulbs, the easiest way to think of a discrete random variable, it is something that you have to count. So a discrete random variable is a set of outcomes that you have to count. A continuous random variable is taking outcomes that you have to measure. And that's the primary difference. And when we look at examples, you'll see some, but we're going to focus today on discrete random variables. So we're going to look at this one here, things that we need to count, possible outcomes that we're going to have to count here. So I want to talk about probability distributions here and the notation that we're going to have. So when we talk about the probability that our variable, our discrete random variable, is going to take any of the possible outcomes, we're going to use this notation: P of x equals, whoops, we'll try that with a highlighter, P of x equals x, where the probability of x being equal to a certain value. So we're looking at the variable x taking the value of little x. So here's a good example. If we're tossing two coins, right? Well, then what's the probability that I'm going to have heads? Well, the possible values that our variable x could be, if I'm tossing a coin twice, I could have 0 heads, I could have 1 head, or I could have 2 heads, right? So the random variable, what are my outcomes? My outcome could be 0, 1, or 2. So I will then look at what's the probability of each of those outcomes happening. So I'm going to look at what's the probability of x equaling 0, meaning no heads, what's the probability of x equaling 1, 1 head, and what's the probability of x equaling 2, 2 heads. Now, we know when we're tossing two coins, those are not all equal probabilities, right? If you look here at these two different graphs, we're a little more familiar with what they're calling it the column graph. You also call it a bar graph, right? So the probability of there being 0 heads is 1 out of 4. The probability of there being 1 heads is 1 out of 2. And the probability of there being 2 heads is 1 out of 4, right? Because it could be tails, tails, heads, tails, tails, heads, or heads, heads, right? This over here is called a spike graph. I like to think of it just as a very, very, very narrow bar graph, just using a line up to a point rather than a bar graph here. So we'll actually see spike graph in examples. But anyway, so that's what we're looking at here. We're looking at the possible values that the variable x could be. So let's look at an example here. We'll get into the probabilities, but let's just look at the possible outcomes and things that x could be. So here's an example. In this supermarket checkout, we have 3 checkout points, A, B, and C, and an inspector checks the scales for accuracy. And if a scale is accurate, then they get a Y, and if it's not accurate, they get an N. So suppose X is the number of accurate weighing scales. What would be the possible outcome of how many of these weighing scales are accurate? Well, none of them could be accurate. Maybe some of them could be accurate. Maybe all of them are accurate. So let's list all the possible outcomes. And so if we had A, B, and C, right, first possibility would be that, well, none of them are accurate. So the outcomes or the value of X would be 0. We could say maybe one of them is accurate, right? So yes, no, no, and that would be an outcome of 1. I could say, what about maybe just the second one's accurate, and that'd be an outcome of 1. Maybe just the third one is accurate, that would also be an outcome of 1, right? And then I could go on. So what have maybe 2 of them could be accurate, right? So maybe not the first one, but the last 2 could be accurate, or maybe the first and last would be accurate. That would be also a 2. Or maybe how about the first and second could be accurate. That would be an outcome of 2. And then finally, the last possibility is all 3 of them are accurate, and that would be an outcome of 3 accurate scales. So those are all of my, all of the possible outcomes. So describe using X. It says the event of there being just 1 accurate scale. So that was part A. Part B, what would be describe the event of there just being 1 accurate scale? Well, if there was just 1 accurate scale, then we would say my discrete random variable x is equal to 1. What would it be if there was at least 1 accurate scale? Well, then we would say x could equal 1, 2, or 3, right? Because, and I should say 1, 2, or 3, otherwise it might look like it's and. 1, 2, or 3, right? Because it could be any of those values, and that would mean that I have at least 1 accurate scale. So for right now, we're just looking at and there's the example in the chart there. So looking at possible outcomes and looking at the possible values for my discrete random variable. Then again, the discrete random variable is the different outcomes that could occur for some experiment. So in this case, I'm looking for what are my possible outcomes going to be in a particular situation, and that's what we're looking for here. So let's start off with an easy exercise. Check out your assignment on section 23A. Just look at numbers 2 and 3, and that'll be it. This shouldn't take you too long, just maybe a few minutes. We're going to go a little bit more into our discrete random variables in the next section, but that'll be it for this first section. For this first one, when you do the assignment, if you look under modules on eCampus, I will have an assignment there listed. You click on that assignment, and then it's going to ask you to upload your assignment. So you can do that of multiple ways. You can take a picture and put it in there. You could scan it in if you have a scanner app, or if you have a scanner at home. You could actually, if you want to use a stylus and do your assignment on a tablet and maybe send that in. If you want to type it, you could do that as well too. Sometimes math gets a little bit tricky trying to type it in. Or you could, like I said, just take a picture. If you're having trouble uploading it on eCampus, go ahead and email it to me. Definitely try to figure out the uploading first. That'll make life easier for all of us. That way I don't have to worry about missing your email or things like that. But if you can go ahead and upload it to eCampus, that'd be great. If you have some problems with it or not quite sure what to do, please ask in the message boards and on the discussion boards, and I'll be happy to answer your questions, or drop me an email. So that's your first assignment. I will also have another one this week as well. We're going to try to do 2 assignments a week and see if we can keep that nice and light rather than doing 1 section a day like we usually do in class. So we're going to cut it down to maybe 4 a week, from 4 a week down to about 2 a week. So if we can do that, I think that'll be a nice light pace that we can go ahead and finish out the year with. So check those out. And if you have any questions, please let me know. I'll talk to you soon. Bye.